Hello there. Let's talk about converting decimal to binary. So decimal and binary, if you don't already know, they're number representations with different bases. So if we have like decimal, it's base 10, which means we have the characters 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to represent a number. We could represent the same exact number in binary as long as you're not using like a fraction or anything in binary, which is a base 2, because in binary you only have a 0 and a 1. By the way, we can use fractions in binary. It's just that when you start using fractions, then sometimes the numbers don't translate precisely in every single case. They often do, but not always. So if you're not using a fraction and you want to convert a number from decimal to binary or binary to decimal, it should work. You should be able to represent the number exactly. Okay, so base 10 means we have 10 digits that we can use. Base 2 means 2 digits or 2 characters or 10 characters. And how do we convert a number? Okay, so the first thing I'd like to do is, let's see, 55432 is what I wanted to do. Let's take a number 55432 in decimal. So we'll say decimal, and we'll convert this number into binary. So the first thing that we do is we try to understand that every single time we have a temporary number as we're converting from decimal to binary, we'll just keep dividing it by 2 forever and take the remainder at each step. The remainder is going to be either 0 or 1 because we divided by 2. When we eventually have nothing left, then we're done, and all of the remainders are going to be the binary number. So let's try it. I'm going to pull up a calculator because I'm not like super sharp at math all the time. I just want to do this quickly. Remove from favorites was already in there. Oh, it's right there. The symbol doesn't make sense. The calculate people have a different symbol, and I'm doing something wrong. It's not showing the right symbol here. I need to fix that. Okay, so 55432. So the first thing we do is we divide it by 2. So I'm going to say 55432. Just write down all the steps. It's a really, really good idea. 55432 divided by 2 is what? It's, something remainder something. Right, so the remainder is either going to be 0 or 1. So I'm just going to punch that into the calculator real fast. Divided by 2, that's going to be 27716. So 27716, and well, we started with an even number, so I can just infer that the remainder is going to be 0. But if you're not sure, you can use the modulo operator. So here, when we use the division operator, it'll tell us what the quotient is. What's the actual, what is that number divided by the other number? But if we use the modulo operator, it'll just give us the remainder. Not all calculators do this. Keep that in mind. If your calculator doesn't actually do that at all, try doing 27716, which was the result, and just multiply it by 2 again. If you have the same exact number as you started with, then you know the remainder is 0. Otherwise, you can subtract the original number, 55432, from the number that you multiplied back up, and then that should give you the real remainder. Hopefully your calculator does modulo, though. For those of you who are ambitious, you can probably just open up a Python terminal and do it that way, because programming languages all have the modulo operator, and Python's pretty easy to get into. All right, so we've done that. We now know that there is a 0 somewhere in our binary result, but because we have this result that is pretty big, we're not done. We have to continue dividing. So I'm just going to take that number, copy paste it to the next line, and divide it again, and just repeat the process. So I'm going to say something divided by 2. It's 13858, 13858, and then I'll just double check myself here, 13858. The original number was even, the 6 was even, so I know there's not going to be a remainder. Pretty much, if it's even, 0 remainder. If it's odd, 1 remainder. That's pretty easy. I don't need to worry about the modulo operator. And then I'm going to do it again. Copy paste 13858 down to the next line. Divided by 2 equals what? Divided by 2, it's 6929. So 6929. Remainder what? 858 at the end there was even, so I'm going to say it's remainder 0. That's like a lot of 0 remainders. For me personally, I like to space my notepad results here out so that everything is lined up. Notice how the R is kind of like askew. So I'm just going to hit a space there to make sure everything is lined up. And then I'm going to do it again. 6929 divided by 2. Maybe I'll hit a space before that division symbol to make sure everything is okay. 6929 is going to be, whoops, I'm on the wrong. Did I accidentally close that? Oh my gosh. I cannot stop myself. What? It's saying that it was already open somewhere. Did I just miss that? No? Okay. Whatever. Okay. So 6929 divided by 2, it's going to be, oh, I forgot. Yeah, this calculator is not going to like round for me. So that makes it even easier. If the result is 0.5, then the remainder is definitely 1. Otherwise, the remainder is 0. So it's going to be 3464 remainder 1. 3464 remainder 1. Space it out real fast. 3464 remainder 1. Okay, and then copy 3464. Forget about the 1. We're not copying that. We're just copying the actual, quotient result. So 3464 divided by 2, 1732. 32, remainder 0, because it was even in the first place. 1732. Oh, there it is. I keep forgetting. Maybe I should pin this to the top so I don't lose it. 1732 divided by 2, it's going to be 866. Whoops, 1732 divided by 2 equals 866, remainder 0, because it was even. Do my spacing. I did my spacing. Then we'll divide again, 866 divided by 2. I don't know, maybe my spacing is kind of dumb. Maybe I should have spaced the numbers and not spaced the operator. That's probably better. Okay. So 866 divided by 2 is going to be 866 divided by 2. It's going to be 433. 433, and it was even, so the remainder is 0. And then 433. Okay, so 433 divided by 2. I'm getting tired of this. I don't know if you can tell. 216. So 433 divided by 2 is going to be equal to 216, and then remainder 1. Space that out. Oh, I messed that up again. Okay. And then space those out, and then everything is good. Okay, so then 216 divided by 2. And of course, I'm just doing this again and again and again. I hope this is not too boring, but I hope you're following along. Another good tip that I like to give people when they're learning new things is do not make the mistake of accidentally memorizing a handful of examples. Try to find as many examples as you possibly can, and every time you practice, use a different example. That way, you will actually learn how to do the thing instead of accidentally memorizing an example. Okay, so 108 divided by 2. Maybe I'll do this again, but with a smaller number, just to make things faster. It's going to be 54, remainder 0, and then 54 divided by 2. I guess I can just do this in my head. I don't really trust myself, so I'm going to do it over here. Okay, 24 remainder 0, because it was even, and then we'll do 27 over here. That's definitely going to be remainder 1. So that's going to be like probably 13 remainder 1. I don't trust myself. I'm going to do it for real. 27 divided by 2, 13 remainder 1, and then put the 13 there. 13 divided by 2 is 6 remainder 1. Oh no, I'm losing it. Okay. 6 remainder 1. 13 divided by 2. Let me just, I'm sorry for double checking. I am honestly not like an internal mind math whiz. And then we do 6 divided by 2. That's just going to be 3, remainder 0. And then we'll do 3 divided by 2 is going to be, 1, because only one of the 2's can fit there, and then 1 remainder 1. And then we have 1 left over, so we'll say 1 divided by 2. We can't actually fit, any 2's into the 1, so it's going to be 0 remainder 1. And now at this point, remember, we're just carrying over the quotient result. We're not carrying over the remainder. So if I carry this over here, 0 divided by 2, the number is always going to just be 0 remainder 0, no matter how many times now. No matter how many times we carry this down. So we know we're done when this number that we're dividing is a 0. We're just totally finished. So now I'm just going to omit that. Well, maybe I'll leave 1 up there just to kind of prove a point. Think about this. If this is actually going to be zeros forever, which side of the number string would the zeros go on so that no matter how many zeros you computed, the actual result wouldn't change? For example, if I had this original decimal number and I decided to say, all right, I'm going to add some zeros to it without changing the result. If I added 3 zeros to the right side, then it definitely changes what number that is, right? The value is now multiplied by 1,000. But if I put the zeros on the left, then the number doesn't actually change. These are junk zeros. They don't mean anything, or they mean nothing. So that means wherever the endless zeros are is actually the left side of the binary string that you're trying to make. Think about it. You know, we're not going to put a bunch of zeros on the right side of a binary string because then we'd be increasing the size dramatically just based on our whims of how many times we try to divide a zero. Instead, if we stick the numbers on the left side, then the result doesn't change, so it's totally fine. Which means if you kind of tilt your head to the left, that's the number, not to the right. So that means, you know, probably intuitively you might have been thinking, oh, the first number, the first remainder we got, that was going to be the first digit, and then we work our way to the right. No. Actually, it's backwards. We have to reverse it. So I'm going to go ahead and, you know, you could, if you want to, you know, you can start at the bottom and work your way up, and then just write the binary string correctly. Sometimes I like to start from the top and then reverse the string later, just as a little brain exercise. So I'll go 1, 2, 3, starting from the top. 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 0, 1, 1. And then I'll reverse it. I'll say 1, 1, 0, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0. And because I just did it this way, this provides a nice opportunity to double check your work, because it's really easy to get things like this wrong. I get things wrong all the time. And so if you can figure out a way to double check your work in 2 or 3 different ways, you reduce the chances of being wrong. It takes a little more time, but it's a really good idea when you're actually, you know, doing work, or like you're taking an exam or whatever. Check your work in multiple different ways. So now that I've done it in the first way, I'm going to do it from the bottom up just to see if I was right. So I'm going to go 1, 1, 0, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0. Does it match? It seems to match, so I'm pretty confident that this is the correct number. Let's just punch it in real fast. I'm going to punch it in on my personal calculator here real fast. Binary and decimal. I'm just going to copy this to my outside calculator just to prove to myself that it works. 55432. Okay, so this is indeed the correct answer. We now understand how to convert from decimal to binary. It's not too bad, right? Let's do another number just for fun. Just something really small. Let's go 632. Okay, whoops, nope. Let's do another tab. We'll say decimal 632 so that this is faster. We start with 632, we divide it by 2. The result is going to be, oh, can I guess this? 350, and then like a 15, and then a 1. I don't know if that's going to be right. Remainder 0. Let me see if I can punch this up. 632 divided by 0. I blew it. Oh, I was thinking of, okay. Whatever. This is why I use a calculator to double check myself. So 316 divided by 2 is going to be, I thought I was so cool too. Like, oh, everyone watching is going to be so impressed that I did this in my mind. Nope. So we do 316 divided by 2. It's going to be 158, remainder 0. So 158 divided by 2, that's going to be, okay, that's 75 plus 4. I guarantee it. So I'm going to do 79. 79. Remainder 0. Let me see if I'm right. Oh gosh, this is going to be embarrassing if I get it wrong. 79, okay. So then now we're going to do 79 divided by 2. Whoops, I spaced poorly. 79 divided by 2 is basically going to be 39, remainder 1. We know it's remainder 1 because, you know, 79 is odd. If it was 80 divided by 2, it would have been 40. So let's just double check real fast to make sure that we're getting it right. It's easy to get things wrong if you're not double checking yourself. 39. Okay, so then we'll do 39 divided by 2. Well, that's just going to be 20 remainder 1. Am I right about that? I don't know. Let's see. 39 divided by 2. Oh, I blew it. What was I thinking? Okay, of course, it's going to be at least 40 if it's 20. Totally blew it. Totally blew it. So 19 divided by 2. Okay, so I'm looking for a lower number, not a higher number. So 18, so that's 9. Let me see, 9 remainder 1. Am I right? By the way, all these shenanigans that I'm doing right now are exactly how I'm going to end up with the wrong result and have to do this whole thing all over again from scratch. But hey, at least it will be more brain exercise. Okay, so 9 divided by 2. I'm going to say 4 remainder 1 because it's odd. We'll do 9 divided by 2 just to double check. And then we'll say 4 divided by 2 is 2 remainder 0 because it was even. I don't think I need to double check it, although I probably should anyway. 2 divided by 2 is going to be 1 remainder 0. Okay, we have a 1, so we actually have to do this one more step. 1 divided by 2 equals 1 remainder 0. Oh, sorry. 0 remainder 0. Otherwise, that would have been infinity ones for no reason at all. So 0 remainder 0, remainder 1. And then finally, we're down to 0 divided by 2 equals just 0 remainder 0. And then we're finished. Okay. Let me do it the first way where I go from top to bottom, then reverse it. 1, 2, 3, 1, 2, 3, 4, 1, 2, 1, 1, 2, 3, 4. Then I'll try to reverse that. 1, 2, 3, 4, 1, 1, 2, 1, 2, 3, 4, 1, 2, 3. Okay. Then I'll do it from the bottom up. 1, 2, 3, 4, 1, 0, 0, 1, 2, 3, 4, 1, 2, 3. Do these two match? Yes, they do. Okay, I think we've successfully done this. We're now semi-experts at converting decimal to binary. Thank you for watching. I hope you enjoyed this video. I hope you learned a little bit of stuff and had a little bit of fun. I'll see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness, which is coming for us all.